Hi folks, my name is Jeff Cox. I'm the engineering director in charge of Bazel at Google. You can reach me at jeffcox@google.com. Just please don't DOS my inbox. I'm here to welcome you to this year's Bazelcon and to talk to you about the state of Bazel. Let me start off by saying that I appreciate your willingness to participate in our virtual event this year and acknowledge the challenges in doing so. No one likes a virtual conference as much as a physical one. I am excited about the possibility of seeing you all in person at next year's Bazelcon. I'd also like to thank this year's presenters. We have lined up a great set of talks for you that I hope you will find inspiring. You can find the full list of talks on the Bazelcon website. I need to also remind you that all Bazelcon participants are required to adhere to our code of conduct, which is also published on the Bazelcon site. Finally, though I don't use Twitter a lot, I will encourage you to use the Bazelcon hashtag on Twitter and to participate in the Bazelcon Slack channel. The Bazel project remains focused on our enduring vision, which is that any software developer can efficiently build, test, and package any project of any size or complexity with tooling that's easy to adopt and extend. Whew, that was a mouthful. With that in mind, I'd like to walk you all through some of our biggest highlights and lowlights over the past year that align with this vision and also with the goal of supporting a growing and thriving Bazel community. I'm really pleased to say that we have good news to share with you on many of the promises we made to you last year. At last year's Bazelcon, I had to acknowledge that the project had accumulated quite a large backlog of issues and pull requests. Over the past year, we have made a concerted effort to address this problem. While we still have more work to do, and likely the work will never end, I'm happy to report that we now have fewer stalled high-priority issues, as well as a low rate of unreviewed issues and fewer untriaged issues overall. You can keep tabs on us by visiting dashboard.bazel.build or by checking out our GitHub project page. Last year, we also committed to improving the experience of external contributors to Bazel. In service of this goal, we have adopted a new governance model, which is now published on our website. The new model both strengthens and clarifies the roles of external contributors, while also reaffirming Google's role as the chief steward of the Bazel project. We continue to welcome the community's feedback on our governance model. One of the key indicators of Bazel's success is the widespread usage of Bazel's remote execution API for builds and tests. This API allows Bazel to do what few other build systems can do: distribute individual builds across thousands of computers to dramatically reduce build times. This year, we have continued to invest in the development of the Remote Execution API and supported the ongoing efforts of the Remote Execution API Working Group. It has been gratifying to see the growth in the quantity and quality of third-party server-side remote execution implementations. We hope this strong growth continues thanks to our support. Last year, I was really excited to announce our ambitious program to move the entire Android platform to Bazel. This program, in my view, is strong evidence of Google's commitment to support the Bazel project itself. This year, working hand in hand with our partners in the Android organization, we have made a great deal of progress on this program. For instance, Bazel now successfully interoperates with Android's existing build system, Zoom. In addition, low-level libraries, various platform-embedded apps, and the Android kernel itself, no small feat, can now be successfully built with Bazel. By next year, we plan to support all rule types needed to build a platform and most platform build targets, and Bazel will be the default build system for new modules as well. One of our bigger announcements at last year's Bazelcon was the arrival of long-term support releases, which many of our users have been clamoring for. Nobody likes a new version of Bazel to break their build. This year, we have delivered LTS version 4.0 and have announced the release of LTS version 5.0 as well. We have also shipped minor releases 4.1 and 4.2 to deliver backwards compatible support for key features such as Apple Silicon support. We continue to ship rolling releases, and overall, the community response to the LTS program has been extraordinarily positive. In addition to being difficult to pronounce, Starlarkification is our ongoing effort to migrate native rule functionality in Bazel to standalone Starlark rules. Doing so will make Bazel much easier to develop and maintain, and also commits us to ensuring that Starlark as an extension mechanism is both featureful and performant. we won't be able to cheat by using the native Java APIs in Bazel itself. This year, we have successfully removed native rule support from Bazel for a number of smaller rule implementations and made significant progress in Starlarkifying the C++ and Java rules, some of the most complex rule implementations in the Bazel codebase. We have also reduced rule technical debt and further improved Starlark rule performance. Be sure to catch Ivo's presentation on the future of language-specific rules in Bazel for more information on this important effort. Consistent with our overall vision, we continue to focus on building functionality that enables Bazel to be better used and extended by the community. One new capability that I'm particularly excited about is Bazel's new support for external dependencies, which we call BZL-mod. With BZL-mod, Bazel projects can register themselves as modules with the Bazel registry, such as the Bazel Central Registry. A Bazel project can then use BZL-mod to fetch external dependencies as modules from a specified Bazel registry. One key advantage of BZL-mod is that a Bazel project need only specify its direct external dependencies. BZL-mod then does a transitive dependency resolution automatically, including version selection. We also have plans for the Bazel Central Registry to support cross-module and Bazel version testing and validation. Be sure to watch Yoon and Shudong's talk on external dependencies during the conference to learn more about this new feature. Overall, I'm really gratified to see the clear growth of Bazel adoption across the ecosystem, including new and novel usage of Bazel that takes place every day. We are reaching an inflection point in our growth and have become the go-to multi-language, multi-platform build tool for software. By next Bazelcon, we will start to see adoption of Bazel by Android platform partners. When complete, the migration of the Android platform to Bazel will significantly expand the Bazel community, and we look forward to welcoming Android platform partners to it. Over the next few years, we also expect distributed builds through the use of the Remote Execution API to increasingly become the standard way the industry builds and tests software, similar to how large-scale cloud-based distributed systems have replaced mainframes and on-prem computing for enterprise production workloads. Finally, we are really excited to see how the community will leverage our new external dependency support, as well as the new Bazel Central Registry. With that, I really want to thank everyone from the community who has joined us for this year's Bazelcon, as well as all of those who have contributed to organizing Bazelcon to make it such a success. We really wouldn't be where we are without the community's active participation. And it's so gratifying to feel part of an active and growing and invested community in our projects. I really hope you enjoy the effort that has gone into all of the presentations we put together. Please also use the Bazelcon hashtag on social media to continue the conversation online as well. Thank you.
Hi, I'm Joe Hicks, the product manager for Build and Bazel at Google.
Hi, I'm Sven Tiffen, Bazel's engineering manager in Munich. Welcome to Bazelcon. Joe and me would like to share more details about some topics that Jeff just mentioned in the keynote session and guide you through this year's conference format. So when we look back, a lot of progress that we made over the last year was actually based on feedback that we received during Bazelcon 2020 and from a survey that we ran in Q1. So thank you to everyone who provided feedback at last year's Bazelcon or participated to the survey. The survey returned a satisfaction rate of 71%, and while showing an improvement over an older survey from 2019, we would clearly like to do much better in the future. We received quite a lot of supportive feedback. For example, many positive comments about Bazel's core features like fast and correct builds, incrementality, multi-language support. We read happy remarks about the renewed long-term support release strategy. We've heard supportive voices about remote execution rules, toolchains, Starlark, and more. However, feedback also showed us room for improvement. One long-standing request of the community has been to improve the management of external dependencies. We've staffed an effort called Bazelmod, which got designed and shaped under continuous feedback from the community over the past year. To learn more about it, watch out for Shudong's and Yoon's talk at the External Dependencies Birds of a Feather session later today. Another big cluster of feedback has been asking for better documentation. We've started working on this with a dedicated team of tech writers. We've also heard demand for better IDE support, in particular for IntelliJ. And also here, we staffed an effort that focused on IntelliJ and that delivered some remarkable improvements over the year. That being said, there have been areas where we have heard the community's wishes, but have not made as much progress as we've hoped to. For example, we know that users would like to see more love for Windows. However, Windows is not a strategic platform for Bazel right now. Therefore, we're not focusing on it. We do encourage community contributions for bug fixes and for other small, well-structured improvements, though. Another area where we've planned to make more progress than we've been able to deliver is about roadmaps and community work. The roadmap on Bazel's website got cleaned up. However, it's not in great shape yet. Improving our roadmaps as well as community work overall will be a focus area for the upcoming year. Speaking about community work, we've recently updated our governance model. And as Jeff mentioned before, the new governance model provides clearer definitions of contributor roles. It also strengthens the role of community-driven repositories that are led, maintained, and managed by members of the community. It also clearly states now that Bazel is a project overall led by Google, which in particular applies to Bazel itself. And we do want to improve the experience of contributions to Google-maintained repositories. We want to review incoming issues and pull requests in a timely manner. We want to ensure important issues are under active development and receive regular updates. And here we actually did achieve improvements over the past year. We reduced the number of untriaged issues to below 100 by improving our triage model. We've reduced the time required for the initial review of newly filed issues. We've been reducing the average time to close of issues as well. However, not all of this has been fully sustainable yet. There's clearly more to do. Looking at the backlog of issues, we want to get better at identifying work that can be taken into scope for Google or the community. We want to manage pull requests in a timely manner, both for merging them, but also by being better in managing expectations when a pull request cannot be merged at foreseeable future. We want to enable more community contributions, be it in repositories managed by community members or in specific code areas in Bazel. In order to make this happen, we need to work with our community contributors and maintainers.
Some of you asked for the opportunity for the community to play a greater role in more key aspects of Bazel. Specifically, a number of community members have requested greater input into remote execution aspects of Bazel. We considered options to move parts of Bazel core into separate repositories, such as Remote Execution Client, but came to the conclusion that keeping the core of Bazel holistically in one repo is the most effective approach. Recently, we've given code owners rights for the remote module directory to community members who have been long-term contributors to the remote execution sections of the Bazel code base. The goal with this addition of non-Google maintainers is to achieve faster PR turnaround by separating the primary code view, which needs a lot of domain knowledge, from the final pre-merge review, which will focus on security, compliance, and compatibility with Google's internal tests. We anticipate that this will result in higher code quality thanks to the bigger group of expert reviewers and faster end-to-end process. We hope that the Bazel community welcomes this change and sees it as a sign of the Bazel community's transformation as it grows with greater adoption. We plan to explore ways in the next year to better support groups of community members and contributors in various domains. Also, keep an eye out for Helen and Cynthia's talk, Join the Party, which provides some tips for new contributors.
We want to thank our active maintainers and contributors in the various rules repositories. We've heard from you that our overall responsiveness is not always satisfactory. We can see how this affects contributions to repositories which are maintained by us. For repositories that are community-driven, in particular rules repositories, the renewed governance model and maintainer roles should ensure that Google is not a bottleneck. We've also noticed and appreciate the energy that the community is showing in organizing better collaboration next to the Bazel Build project. We cannot always keep up the same velocity as community members for discussing general suggestions like policy changes. However, we've been widening our communication channels and overall availability with the goal of improving our responsiveness. We're also looking forward to collaborate with initiatives in the community. Based on this, we plan to further improve the governance model for the Bazel project.
At the last Bazelcon, many of you mentioned that you're hoping for better Bazel documentation. While there's still room to do more and do better, there's been a lot of improvement in Bazel's documentation in the last year. We've added a dedicated team of tech writers, surveyed users, and ran fix-its to address user pain points. In response to your feedback, we refactored navigation to make it easier to find content, improved consistency and freshness, and addressed long-standing documentation bugs. We've also added new content on subjects including hermeticity, sandboxing, persistent workers, the build event protocol, release versioning, backward compatibility, multiplex workers, dynamic execution, and more. Right now, we're working on migrating the docs to better infrastructure that'll have more robust accessibility features, will include localized content, and much more. While we've made a lot of updates to the docs, we encourage community contributions. Feel free to send us documentation pull requests when you find something is broken or needs an update.
Speaking of things that are broken or need an update, we've heard your request for fewer breaking changes for Bazel in the past. And at last Bazelcon, we announced moving Bazel to a long-term support release model. And this model got launched this year. We've released Bazel 4.0 as first LTS release, delivered 2 updates over the year, and started to prepare Bazel 5.0 at the time of recording. LTS release tracks provide a stable platform for end users. Within a major LTS version, all updates are fully backwards compatible and won't break your builds. Updates may include upgrades for platform changes. For example, we've added support for Apple Silicon with Bazel 4.1. Updates also include fixes for important issues. For example, we've ported around 50 fixes for remote execution to the 4.0 release track over time. Rolling releases give contributors and rule developers immediate access to vetted binaries near ahead. However, rolling releases will contain incompatible changes, which are more likely to break your build. We believe and received supportive feedback that this simplifies using Bazel. That being said, this model also creates some challenges for rule authors in particular, and we will provide more guidance on strategies how to keep their rules compatible with release tracks.
We've also received a clear signal that the Bazel community would like to have better support for the Bazel plugin for IntelliJ and faster, easier updates for new IntelliJ versions. As a result, we reviewed the entire issue backlog and focused on improving the releasability of the plugin. We have made significant strides on IntelliJ support. We've improved the development, testing, and release process to enable the Bazel plugin to move to the new IDE versions quicker, which means that the plugin can be developed against IDE EAPs now. This work allowed us to support IntelliJ 2021.2 on the day it was released. However, contributions towards compatibility with new versions is something we'd like to encourage the community to take on. We're actively looking for contributors to help support IntelliJ 2021.3. Additionally, a regular meeting has been established for anyone interested in IntelliJ support for Bazel, especially contributors. We've laid a foundation for the community to contribute functionality and would prefer that the community support use cases that the community requires. Check out the IntelliJ channel on Slack or watch for an email to Bazel Discuss for more details on how to participate. Detailed instructions about contribution best practices can be found in the Bazel plugin for IntelliJ GitHub repo. Check out the URL listed on this slide, github.com/bazelbuild/IntelliJ #contributions. Next, I wanted to talk a little bit about the great work that the Bazel experts have been doing for Bazel users. The Bazel Experts program has curated a list of companies who provide specialized consulting and services to Bazel users. Many seek out their help with a difficult migration, a complex language rule, or implementing remote execution. The Bazel experts have demonstrated a proficiency in one or more aspects of Bazel and build technology. We don't prefer one over the other. Each have their strengths, and if needed, we recommend that you work with them to see if they're a good fit for your organization. I want to thank the Bazel experts for all their hard work in supporting users. I also want to extend a welcome to any companies who wish to become Bazel experts. contact product@bazel.build if you'd like to find out more about joining the Bazel Experts program. Now, I wanted to take a minute to ask for your feedback. While we can tell Bazel adoption is growing through signals such as PRs, issues, and Bazelcon presentations, we don't have a lot of firm quantitative data on Bazel usage. We want to ensure that we're engaging the community in a thoughtful and considered way. Understanding how Bazel is used will help both the Bazel team and the community know how and where best to invest effort. This would also help us to shape the roadmap to address the most important requirements or most popular functionality. We'll send out a survey to all registered attendees after Bazelcon to ask for your feedback and ideas about how we can more systemically and holistically understand Bazel usage.
Looking at the next 2 days of Bazelcon, remember that there's a continuous Q&A in the area right below this video while each of the sessions is running. There might be a slight delay between asking your question and getting an answer from the right person. We also will have a live Q&A with the Bazel team on Google Meet at the end of the day tomorrow. The session will be limited to a maximum of 500 attendees and is open to the first that join. Also, Birds of a Feather sessions will be live via Google Meet. Each session will feature some lightning talks and have time for discussion and questions with the presenters. Please keep in mind, whether you'd like to ask questions in the Q&A during the stream or participate to the interactive sessions, remember the code of conduct for Bazelcon so that everyone can have a pleasant and inclusive experience at the conference. Finally, we will send out a survey shortly after the conference. Please respond to let us know what you liked and where we could improve both Bazelcon and the Bazel program.
I wanted to take a minute to thank the Bazelcon presenters and everyone that worked so hard to make Bazelcon 2021 a reality. While it's difficult being physically distant from the Bazel community, we hope that this year's virtual Bazelcon will help bring us together to exchange ideas, connect with each other, and remind us that we're not alone. And we hope that we'll see you all again in person for the next Bazelcon. And now, stay tuned for the action-packed presentations both today and tomorrow. Watch out for these and other great talks coming up on Bazelizing a gigantic iOS app, external dependencies, bias busting, license compliance, hermetic vignettes, and more. Thanks again for coming. We hope that you enjoyed Bazelcon 2021.
Vielen Dank and enjoy the conference.
Hello, my name is Lauren Ewing, and I'm an HR strategic advisor, executive coach, and diversity, equity, and inclusion champion for the Alphabet companies. I'm grateful for the opportunity today to talk with you about a topic that is really important, not just for how we work together, but for the way we actually think about the work that we do every day. That topic is implicit bias. In this brief session, I plan to walk you through what implicit bias is, why it's relevant in the broader context of diversity, equity, and inclusion, and what we can do to mitigate it. And I hope that by the end of this session, you'll walk away with greater curiosity and greater commitment to furthering yourself on your bias mitigation journey. Let's dive in. So, what is implicit bias? Well, simply put, implicit bias is when our brains make quick judgments and decisions based or beyond our conscious awareness. And to help illustrate this, I'd like you to come with me to this scene. Now, some of you may recognize this as Times Square in New York City. And for those of you who haven't visited Times Square before, you can see from this scene, much like this scene, that it's characterized by things like bright flashing lights, billboards, music blasting, people everywhere, total sensory overload. Well, I thought that this would be a pretty good analogy for thinking about how our brains process information. Now, for starters, in every moment, we receive 11 million bits of information. Yet, we can only consciously process just 40 bits. So what that means is that 99.999996% of of the information that we process is beyond our conscious awareness. So, in other words, when we are presented with a lot of information, much like the visuals of Times Square, our brains start to take shortcuts to help us parse quickly through the data and make decisions quickly. And we end up relying pretty heavily on pre existing beliefs and learned associations to help those quick decisions. Our brains also take shortcuts when we don't have enough information, right? Our brains try to fill in the gaps. So, for example, let's take a look at the screen. On this image, we have a white background and some black dots, dots that are of irregular sizes, and I can provide you the context that these dots have some relation to each other. What do you think you see? Well, if you haven't figured this out right away, I'm going to add one more piece of context, and that's motion. So now, what do you see? Some of you might have been able to guess right away that this is a dog, a Dalmatian to be specific. And in order to come to that decision, you likely had a few factors at play. First, you had basic observations. You saw the white screen with the black dots on it, and then you had some additional bits of context. One, that the dots related to each other in some way, and then I added the context of motion. But then the space between those pieces of information to the decision you ultimately made probably was filled with schemas and other learned associations that led you to the conclusion that this was a Dalmatian. Those associations could have been things like having seen a Dalmatian before. Maybe you know someone that actually owned a Dalmatian. Or maybe you saw the movie 101 Dalmatians and that really stuck with you and that led you to associate with this right away. But regardless of how you got there, this just highlights that implicit bias lives within the gaps in our understanding, and our brains quickly seek to fill it. So, our ability to make quick decisions saves time, and it also can make the difference between a matter of life or death. So, it has and can serve us well in many cases. However, our implicit biases can sometimes take on a different significance when applied to people. So, to help highlight this, I've got one more example for you. Imagine that it's your morning commute to work and you've just stepped onto a train car that looks much like this. The train is pretty full, but you do a quick scan and you notice that there are 3 empty seats. And each of these seats happen to be about equidistant from where you're standing. Next to each of these seats, there is an elderly person, a person wearing business casual, and a person with multicolored hair and facial piercings. So, quick decision. Which seat would you quickly claim and why? Now, as you think about your decision, what if I gave you some additional context? What if I told you what race each of these people were? Or gender, sexual orientation, educational background, socioeconomic status. What if one of these people vaguely resembled somebody that you know? How might these additional pieces of context influence your decision making? And what associations do you think might be triggered when you encounter these bits of information? Well, ultimately, there's no right answer here. But this example serves to highlight that in a single moment, you can make a decision about these people without fully realizing what implicit associations are coming into play when you make the decision. But when it comes to people, even the tiniest bit of bias can have really big consequences. Think about this, beyond the people in the train car. Consider how this might show up in the way that you evaluate team members that you meet for the first time, or the way you think about your user groups for your research and testing, or your customer segments for the clients that you serve. The particular type of bias that we're talking about related to people is called stereotype bias, when perceptions are skewed based on non-objective observations about a person or group of people. And stereotype bias doesn't necessarily work alone. it often works in concert with other types of decision-making bias that can ultimately impact people. Now, a quick Google search will yield lists and lists of all the different types of bias that are out there, and I'd encourage you to take some time to do that research. But for the purposes of our discussion today, I'd like to cover 6 types of bias that that you might encounter in your day-to-day. And as I talk about each, I'd like you to consider, when might you have encountered this type of bias? What was the context? And what were the outcomes of that bias coming into play? So first up is accessibility bias. And this one is simply the acknowledgement that we may have a lot of information in our brains, but when we're ready to make a quick decision, we access a subset of it, like sort of like the low-hanging fruit, in order to make the decision, and we don't necessarily seek out other information or information that we don't already know. Similar to this is availability bias, otherwise known as recency bias. And in the spirit of low-hanging fruit, it's the data in your mind that you're able to access because you've acquired it most recently. So when you think about the ways accessibility and availability bias can come into play, we see this sometimes with performance assessments, especially on the recency bias side. When you think about all of the body of work that someone could complete in a given time period, yet when their performance is being evaluated, the accomplishments that happened more recently end up getting weighed and considered more heavily. Another instance of this may be conducting user research with users that are just most available versus thoughtfully curating the representation that you feel that you need for your user groups in order to do your testing. Third type of bias is confirmation bias. And this is one that we see a lot, especially these days, be it on the internet, news channels, or political elections. And it's when we seek out or gravitate toward information that already confirms the things that we believe to be true. So sometimes this can play out in really only seeking feedback from those that you think are going to agree with you instead of engaging with the stakeholders that you think are going to slow down your decision-making process because they tend to bring different perspectives. And really consider how often that happens in our day-to-day. Next up is anchor bias. And this is one where you have some comparison value in your mind against which you compare others. So this can come up, again, with the performance evaluation process, with thinking about how ratings are assigned. Think about how often we look at the ratings from the previous cycle to determine what rating a person should receive in the current cycle, instead of just looking at their body of work for that current cycle and determining the rating independently. Another example is with hiring and thinking about who you're going to fill a role with by considering the outgoing person for that role, instead of using structured criteria to evaluate your candidates. Next up, we have overconfidence bias. And this is one that can be really common in work environments where the work is highly specialized, people are highly educated, and in general, it's culturally reinforced that you should appear knowledgeable at all times about the decisions that you make. And so this bias could lead us to lean away from engaging with cross-functional stakeholders who might challenge our beliefs, or it might lead us to not take action upon constructive feedback that we receive because maybe only one person has said it and you have certain beliefs about the person that delivered the feedback. And finally, I'd like to cover affinity bias, also known as like me bias. And it's one where we gravitate toward people that are like us. And it's very natural to do, but imagine how often this plays out in hiring, in forming teams, in allocating work, in deciding who gets promoted. Now, while there are people that clearly benefit from this type of bias, it is one that also can serve to create the in-group, out-group dynamic, and also consider who ends up getting excluded as a result of this type of bias. So overall, I know I ran through these bias types very quickly, but an important part of the journey toward mitigating your biases is to be able to name them. Because once you're able to name them, then you're able to actually notice them in the moment when they're happening. And that increases the chances that you'll be able to squash that bias, check it, do something different in order to eliminate that bias in real time. And all of these types of bias serve to limit the way that, or the perspective that we have when we're making decisions about people. Now, limiting beliefs like these and these limiting perspectives and assumptions often show up in some of the well intentioned and seemingly innocuous comments that we sometimes hear around the workplace as it relates to diversity, equity, and inclusion. I'm going to put some statements up and think about the degree to which these sound familiar to you. We're a meritocracy here. Bias doesn't exist. I don't see color. I treat everyone the same. What's so wrong with, focusing on the majority if the data supports it? And if so much of my bias is subconscious, I can't do anything about that. Have you ever thought any of these things yourself, or have you heard them said around your workplace? Well, the common thread across all of these is that each of these mindsets provide a limited worldview, they lack nuance, and they actually can ultimately be pretty harmful in orgs and for people who consider themselves to be diversity, equity, and inclusion conscious. So consider how stereotype bias and other types of implicit bias might be showing up in each of these. Now, for the purposes of today's discussion, since I don't have much time, I'm going to do a little bit to unpack each of these mindsets, but I'd like to propose to you a way that you can reframe each of these ways of thinking so that you can transition to discussions that are more conscious and nuanced, ones that will actually advance DE&I initiatives. So, in terms of meritocracy, it's important to note that oftentimes when people talk about this, they talk about it as if we've already arrived, as if it's already been achieved, versus talking about it as an aspirational goal. And in this case, the thing that often detracts from meritocracy actually being achieved relates to our understanding of how privilege, hierarchy, power differentials, and the systemic disenfranchisement of underrepresented groups can contribute to the creation and sustainment of inequity. So I invite you to take on a mindset of exploration when it comes to meritocracy. Really consider and take interest in understanding how dynamics like these can serve to reinforce inequity, because then you can do the work to change your systems, your policies, and your processes to ones that ultimately can bring your organization closer to meritocratic aspirations. Next up is the color blindness way of thinking. Now, I wish it were easy to just say, I don't see color and therefore it doesn't matter, it doesn't exist, because that's what's implicit in this sort of statement. But discussions around saying you don't see color ends up lacking the nuance of understanding the actual differences in the lived experiences of those who are in underrepresented groups. So for this one, I invite you to take on a mindset of empathy. Seek to understand, acknowledge, and respect the differences between yourself and others to drive more empathy and enable you to create space for others to thrive. Next up is the majority rules mentality. Now, the thing about this one is if you only focus and attend to the needs of the majority, then the needs of those who are underrepresented in an organization will continually be left to the side. And it's going to be really important that you treat the stories and the experiences of those who are on the fringes or who are marginalized as just as valid as those who are of the majority. It's not only the right thing to do, but it also is just good business. Because ultimately, there's an inherent scarcity mentality that if we pay more attention to those in majority, then or in the underrepresented groups, then we're taking something away from those that are in the majority. But I invite you in this case to take on a mindset that is more abundant. If you care about diversity, equity, and inclusion, then the stories of those that are underrepresented should be heard and elevated. Even further, it is already a known phenomenon that by attending to the experiences of those that are marginalized and catering more to them, you actually might uncover insights that are beneficial for the whole. There is an effect that is called the curb cut effect that I would encourage you to read up a little bit more about. But this is an exact example of what I just described. Those cuts in the curb on the sidewalk that you notice and that are very commonplace, those originally came about as an accommodation to those who are wheelchair bound to enable them to cross the street. Now, once those curb cuts were put into effect, it was regarded as beneficial for a broader audience. People who are pushing strollers or shopping carts, people who are walking with canes or differently abled in other ways. So ultimately, thinking about those that are on the fringes is going to be important and a game changer because ultimately everyone can benefit from that. And by the way, closed captioning is another example of the curb cut effect as well. And finally, when we talk about the fact that much of our way of being is subconscious in terms of the way we process information, so what can we do about it? Well, I'd invite you to take on a more agentic mindset. And fortunately for you, in the remainder of this session, I'm going to run through some quick tactics and tips that you can consider in order to interrupt your biases and drive greater self-awareness and thoughtful intervention on this topic so that you can really make a difference. But before we transition, I wanted to close with this last thought. Mindset matters. So as long as thoughts like the ones I just stated and just reviewed proliferate in your organization, or if you continue to allow these beliefs to justify your actions or excuse your inaction, then progress toward greater equity, diversity, and inclusion will be stalled. And implicit biases and limiting beliefs can be like a wrecking ball to your DEI efforts. So just think carefully about your commitment to this work and the ways in which you can work through your bias mitigation journey to enhance and support and uplift these efforts. So how can we mitigate implicit biases? Let's get to some strategies and move ourselves along this spectrum from awareness to action. Now, the simplest way I can answer this question of how can we mitigate implicit bias is recognizing that there are two efforts that need to happen in parallel. One is looking inward, which involves heightening your sense of self-awareness so that you can check your own biases in moments when it really, really matters. And then looking outward. It requires you to pay close attention to how you interact with others and with the work that you do. And think about how bias flows through systems, and think holistically about how bias can proliferate so that by identifying these things, you can really start to remove the gaps in information, remove the bias blind spots, and drive greater accountability and action around this topic. Now, to further unpack this duality of looking inward and looking outward, I thought I would summarize some of my key tips around 5 principles. The first one is get comfortable with discomfort. Now, it's really important in bias mitigation work to know your story and own your story and start to identify ways in which you may actually be more susceptible to relying on your assumptions and quick judgments in really critical moments. And so the best advice I could give you is to be ready to confront that which makes you uncomfortable and possibly ashamed, embarrassed, etc. Because that's where the learning is. That's where the growth is with this work. So grasp these moments tightly, attend to your emotions, recognize and reckon with them, and really think about how you can overcome these feelings to really make some progress in noticing and taking action against the moments of bias that you may encounter. Next up is be humble and be curious. And this is something that I truly believe in. Humility and curiosity are not only attributes that make for strong leadership, But it also is so important to the bias mitigation journey because humility is recognizing what you don't know. And then curiosity is seeking to understand the things that you don't know. And that's part of bias mitigation. Being willing to pause, give yourself space to check in with yourself, become more aware of how you're moving through the world and how your thought processes are formed, and start activating your curiosity about your own thinking and others to further your understanding. But then the curiosity extends to your interactions with other people, where you start to listen, acknowledge, validate the stories that are of people that you work with or that you want to be in relation with, in terms of understanding what their lived experiences are, and practice perspective taking. All of this is an exercise in empathy building. But also, I realized I forgot to mention question the assumptions. Be willing to engage in self inquiry so that, and also with others, so that you can question the assumptions that are being made and really challenge them and figure out where assumptions may need to be put to the side to create more objective decision making. Next up is be resourceful. And this means taking ownership of your own education in this space. Now, we're fortunate to have so many thought leaders and scholars who have written podcasts or who've written books, have spoken on podcasts, have created documentaries, and all kinds of media to educate on the lived experiences of marginalized groups. So seek those out, do the work, treat this like a research project as you would any other work that you would do, but really come from a place of empathy and connection building. Now, I mentioned acting responsibly because I wanted to note that sometimes part of the education means that you may be tempted to go out and engage with people that you know who are from underrepresented groups and asking them about their experiences. Now, there may be some who are more than happy to share about their experiences, but also recognize there are people who just want to show up and do their jobs and exist without being reminded of their past traumas. So tread carefully and be mindful when you start engaging with others. But also think about progress over perfection. That means keep moving in a positive direction with your bias mitigation journey, and recognize that this work is a marathon and not a sprint. So sometimes it may feel like progress isn't being made or that you're not making progress with your bias mitigation effort. But habits are formed through repetition. So the more that you continue to check yourself, educate yourself, engage with each others in useful and inclusive ways, that's going to help you start chipping away at some of the biases that you hold. Next up is aim for positive impact, not just positive intent. Now, as I've said before, even a tiny bit of bias can have big consequences, a ripple effect. And it often happens in this space that people want to rest on the laurels of good intentions and well meaning behavior. But positive intention can still lead to negative impacts on underrepresented groups, and that cannot be excused. So just know that the dream here is to have positive intent and seek to minimize harm. And if you find that you ultimately have unintentionally harmed someone as a result of your well-intentioned actions, then it's important to apologize sincerely. And the way that you do that is to first acknowledge your responsibility in creating that harm, commit to repairing the solution, but then, very importantly, reflect on what you'll do differently to prevent it from happening again. And last, I'd encourage you to be opportunistic. Now, regardless of what your role or your level is in your organization, there is some sort of opportunity for you to mitigate bias, not only for yourself, but for the work that you do. One place to start is with your team dynamic and thinking about ways to improve psychological safety within your organization and create environments where people feel comfortable to share different perspectives. And ultimately, that leads to greater innovation. And that's something that's pretty well documented. But another way to think about this is actually interrogating your systems, your policies, your processes, the way work gets done. Think about what assumptions might be made about the people that you team with, or who contributes to your products? Well, who are the voices in the room? Think about how bias might be showing up in the way that you design, build, research, test. Or if you're a manager, leader, or in some other position of influence, figure out who's in your inner circle. Who are the people that are most influential in the decision making process? And what role can you play to create space for everyone to contribute, even those whose opinions may be underrepresented or in the minority in the room? So, another aspect that is important here is around connection, practicing allyship, advocacy, and building community. And this is something that's really important for getting proximate to people who have different perspectives so that you can figure out how to be more inclusive. So, think about the community that you can build in the position that you're in. Think about the opportunities overall that are before you. There is so much to be done, and we need everybody to be mobilized to think about this. So, in conclusion, as you come to understand the way your biases may be affecting others or the way that you work, hopefully these 5 principles will help you set yourself on a path to really creating some positive intention, creating more self awareness and awareness of the world around you. And then finally, coming to a place of tangible action because awareness can only be scaffolded by action. So ultimately, I'm confident that every single one of you have have the potential to do a lot of great work in this space. All of you can be agents of change, but remember that the change starts with you. So ultimately, let's consider as much as possible the broader impacts of the things that you do on others, and consider those whose voices are could seek to be elevated. Think about the ways that decisions can be done differently and offer yourself as a space for listening, for understanding, for those who could use that piece of connection. That concludes my talk today. Thank you for listening, and I wish you well on your bias mitigation journey.
Hello, everyone. I'm Benjamin. Currently, I work as a software engineer at EngFlow, where we're working to make everyone in the world have fast builds. And in this talk, I'd like to talk about a concept which gets thrown a lot around in the Bazel community and the build world more generally, hermeticity. And I'd like to explore this concept with a few different stories which all revolve around hermeticity. So this is not a talk with a strong driving central point. I just want to kind of broaden the knowledge people might have about hermeticity. So let's get started. And the first thing I'd like to do is begin, as one might, a mediocre essay one's writing in secondary school by giving a dictionary definition of hermetic. So the gold standard, the Oxford English Dictionary, defines hermetic as an adjective that is relating to the airtight closure of a vessel, especially a glass vessel, by fusion, soldering, or welding. So that's not immediately applicable to software builds, but we will be getting to that shortly. First, though, we'll note that the definition is not the only thing the dictionary has for us. The OAD also tells us the etymology of the word. And I'd like to tell you about the etymology of hermetic, since it's a surprisingly rich story. But before even I do that, I'd like to say a few things about false hermetic friends. So the word hermetic shares a spelling and sound similarities to a few other words in English, and that's partially because of vowel mergers in a few English dialects. But these false friends can cause confusion and give us a false sense of where the word comes from. So first of all, we have this guy in this slide here. So this is Charles Hermite. a French mathematician from the 19th century. So he was a pretty productive fellow. He proved that Euler's constant E is transcendental. It's not the solution to any algebraic equation over the rational numbers. And he also lent his name to the mathematical adjective hermiticity, which is suspiciously close to hermeticity. However, hermiticity refers to self-adjoint linear operators, not related to air-gapped glass vessels. We also have this other one, hermits. So sometimes someone who's a whole lot less excited about build tools than me has overheard me being enthusiastic about hermeticity and thought I was talking about hermiticity, a state of seclusion away from the demands of society, aka a hermit. So hermitage has a long history, especially as a religious practice. In 18th century Britain, though, it took a particularly strange turn. And it was fashionable at that time for wealthy landowners to employ a garden hermit on their vast estates. And the garden hermit would live on the grounds in a hermitage, as is romantically portrayed here. And the garden hermit would serve as visual entertainment to the owners and their guests. And sometimes the hermit would even dispense advice and counsel to guests that sought him out in his hermitage or rookery. On the surface, hermits are pretty unrelated to build tools. I think, though, that we may want to treat our build actions a little bit more like garden hermits. Keep the compiler and its embarrassing to undefined behaviors off in the garden, and occasionally feed it little bits of C++ when we're far away from polite company, just in case its output is particularly nasty. But anyway, after those false friends, we can finally come closer to the real origin of the word hermetic, and that is the Greek god Hermes, represented here on the left. So Hermes was the swift herald god for the Greek gods. He had winged sandals for that purpose. And among other things, incidentally, he was the protector of orators. So I'm going to ask his blessing for this talk. So it's pretty clear, you can see the relation between the words hermetic and Hermes. But that's actually not the full set of the etymology. We also have to deal with the beaked character on the right here. And that is the Hermes Egyptian counterpart, the moon god Thoth. So in Egyptian mythology, Thoth had many weighty responsibilities, including inventing writing, judging the hearts of newly deceased people in the underworld, and maintaining the stability of the entire universe. So it must have been a tough job. So how these guys come together is that in about 200 years before the Common Era to about 1400 years after that, numerous philosophical and scientific and religious books and tracts were written, and they are attributed to a fusion of Hermes and Thoth. And this fusional author was called Hermes Trismegistus. I do not claim that is the correct Attic pronunciation, but it will do the job. Hermes Trismegistus means Hermes the thrice greatest, which is one of the greatest appellations you could wish for. The collective works of writings which are being attributed to Hermes Trismegistus is known as the Hermetica. And one of the main things that the Hermetica is interested in is alchemy. So this is the sort of pseudoscientific processes of turning lead into gold or creating the elixir of life and other kind of fantastical things that people thought you could do with chemistry. And one of the key pieces that the Hermetica advises you need to do alchemy is an airtight glass container. And so that is a hermetically sealed container. And so that finally explains the origin of the word hermetic. And but by the way, the Hermetica and alchemy are a really rich source of names. And if you're looking to create something new in piece of software in the build tool world, I really recommend looking there. I'm very much looking forward to the next sandboxing technology called Trismegistus. I'll have high expectations, of course, for it. So after that historical diversion, we can finally come to the point. The definition of hermetic for software builds. A hermetic build is one that always returns the same output by isolating the build from changes to the host system. I took this definition from Bazel's documentation, and that documentation page has a whole bunch of information about hermeticity. In addition to this definition, it discusses the benefits of hermeticity, such as parallelism, security, and improved debuggability. An implication of this definition is that the dependencies of a build setup are completely understood by the build tool, and consequently the humans who wrote it. To me, that is the heart of hermeticity. Leave me nothing implicit. We can also think of the sources of non-reproducibility, such as builds depending on the current time or absolute paths. We can regard those things as potential build dependencies. Then the goal in making our build hermetic and reproducible is to eliminate all these unwanted dependencies so that our builds are hermetic and reproducible across different users, time, and machines. The Bazel world is, of course, not the only community interested in hermeticity for builds. A major force in the wider open source universe is something called the Reproducible Builds Project. Here, reproducible is basically a synonym for hermetic. The Reproducible Builds Project is closely related to several Linux distributions, and one of its main projects has been making package builds in various Linux distributions reproducible. Since what Linux distributions package encompasses so much software in so many different languages, build tools, and conventions, the Reproducible Builds Project has had a large impact across the open source world. The project has developed tools and documentation aimed at finding and squashing systemic sources of non-determinism in build tools. One of my favorite tools from the Reproducible Builds project is a command line utility called diffoscope. Diffoscope is what one uses to debug why two build outputs that are supposed to be the same are different. So, of course, we've had textual unified diff tools for a very long time, but diffoscope extends that to all sorts of binary and archive files because those are commonly the outputs of build steps rather than easily to diff text files. For example, on this slide is an example of diffoscope detecting the difference between two strings in an object file embedded inside of a static archive. It's much easier than staring at a hex dump, I'll tell you. And I've used diffoscope many times to debug non-deterministic Bazel build actions. So if you have that problem, I encourage you to check it out. Another major tool in the build world today is Docker. And unlike diffoscope, I can't really muster unmitigated enthusiasm for Docker. Docker is presented as a solution to a smorgasbord of problems, and it does address some of them quite well. For instance, Docker has done a lot to promote the wider use of Linux containers and their isolation mechanisms. It's also helped a lot to reorient developers' abstractions to emphasize an application-centric rather than a host machine-centric development and deployment workflow. More specifically, in the world of local development, Docker has largely alleviated the infamous works on my machine problem. To call a build done in Docker hermetic, though, I believe is quite a stretch. Because Docker makes it really easy to build multi-gigabyte, non-deterministic images with a huge number of unknown dependencies. To drill in on those problems, let's look at a really simple but Docker file with a bunch of representative problems. The first line here directs Docker to base the image we're building on an image from Google's distro-less container project. That's fine, but this from line does not specify a particular version of the image. Instead, it opts to use the latest image tag. That tag is updated whenever a new version of the image is pushed, and that means the final image that we're building depends on the state of the image server at the time that the Docker file is used. Similarly, Docker makes it easy to download arbitrary blobs from the internet and add them into the image. The URL in this highlighted line at least has a version number, which is more than can be said for the from line we were just looking at. However, the add line is relying on the good graces of the host it's downloading from, example.com, to modify releases once they're placed on the web publicly. So even if the example.com admins are very careful and they only practice immutable deployments, hackers of example.com could replace the archive with whatever malevolent software they desire, and the Docker file would be none the wiser. The software could also just disappear too if the host example.com goes out of business. Finally, in Docker files, we have the ability to invoke arbitrary commands, and I think the problem with non-reproducible is fairly clear here. But even if your program is very, very careful to be deterministic and reproducible, it's very tricky to produce bit by bit identical results. For example, writing files will generally update file system metadata with the current time. So that means even this simple command, which is just writing a static piece of data into a file, still is going to cause timestamps to be written into the image. And commands that reach out to the network repeat all the pitfalls of the add command that we were just talking about. And so consequently, most of the commands that we'll find in a Docker file are really not rigorously reproducible. The conclusion of that is that once you have created a Docker image, there's no guarantee you'll ever be able to get the same one again. There's a workaround for this problem, though. We'll archive whatever image we've created and remember its cryptographic hash. When we want to reproduce the image, we'll just go and download the archived one and check if it matches a hash. Presto, it's technically reproducible. I call this trick stash and hash. It works fine until we need to change one line in the middle of the Docker file and can't create a new image without including many other unintended and perhaps undesirable changes. Hermeticity isn't the only desirable property subverted by sloppy Docker files. It's easy to create images that are made of software with unknown licenses and completely unaudible, which makes security teams pretty nervous. So while Docker has been in many ways a boon to those of us concerned with builds and build tools, it doesn't replace discipline and having a clear understanding of one's dependencies. To contrast with stash and hash, let me sketch how I dream of development environments working at tech companies, large and small. Many companies have complex provisioning processes that must run on developer machines before any coding can start. I only want to require two dependencies, Bazel and some version control system. To get started, a developer installs Bazel and checks out the working copy of the company repository. So here I admit that I am a monorepo partisan, but the scheme actually doesn't depend on you only having one repo. Then, once they have the repo in Bazel, those are all the steps they need to do. Using Bazel, they can build and test any code in the repository. They don't need to know anything about language-specific package managers or special build tools or install anything on their system. Hermetic toolchains and sandboxing ensure that they get the same result as any other developer and that anything they've installed on their system does not affect the build. It's not just developers that enjoy a simpler setup with this scheme. CI machines don't need to run any complex long provisioning system either, and applications can be deployed with minimal containers. Now, this is just a dream, of course, and there's many places where this will collide with reality and have to be fudged a little. For instance, forcing language-specific package managers and compilers to behave under Bazel's constraints is often a long slog, although it's been done for many of the most popular languages. We must also consider questions like, what happens if people are using different operating systems, and how are system-level dependencies like GPU drivers or kernel extensions handled? But despite the inevitable implementation kinks, I believe this is a glowing cynosure that we can all be happy and heading towards. A last hermetic topic that I like to touch on is the construction of a hermetic and reproducible toolchain for a language. This is the sort of toolchain that would be useful to implement my Bazel dream, as shown in the previous slide. And a few modern languages, most notably Go, have this out of the box. So we're going to talk about one where it's a little bit harder, C and C++. And this is actually quite a fraught history. But let's talk more specifically about what we want out of this hermetic C++ toolchain. Okay, so we're going to build our compiler from source. And obviously to do that, we're going to need some sort of minimally functional host compiler that already exists in order to do that. But we want to be able to reproducibly produce our compiler from a host bootstrapping compiler. We also want any artifacts that our compiler produces that need any runtime libraries. We want those runtime libraries to be reproducible. And we're going to assume Linux for simplicity. And the reason that it's simple is that Linux is special among modern operating systems in that the syscall interface is stable, and not just the interfaces of native system libraries like libc. So that means that one can ship a completely separate user space compatible with any Linux distribution. We're going to be seeking to keep our runtime libraries completely separate from any system of their system counterparts. Our runtime libraries will only talk directly to the kernel, and this prevents any breakage if the system libraries change. The compiler itself will be linking our independent set of runtime libraries, which completes the isolation of the toolchain from the system. So we've been talking a little vaguely about compilers and language runtimes as two components, but we need to lay out the specific constituent parts a little bit more specifically. The first thing that we probably think of in a toolchain is the compiler, so GCC or Clang. But we also need some utilities to manipulate binary files. So most importantly, this is the assembler and the linker. So there's GNU implementations of those, which are widely used, and also LLVM has newer reimplementations. So there's this toolchain of components, and then finally, there's runtimes that the compiler products link when they're running. So in the C world, the most important one is glibc, which provides the C standard libraries. Compilers usually provide a runtime library too. For GCC, there's one called libgcc. And C++ has its own standard library too, so libstcc++ or libc++. Keep in mind, though, there's not any clear dependency hierarchy between these components. The compiler is usually a C++ program too, so it needs a glibc and a compiler runtimes to work. And those, of course, need a compiler to be turned into object code. Now, how do we actually go about building all these toolchain components to our exacting reproducibility and hermeticity standards? This is an issue where the long history comes in. And part of that history is something called cross-tool. So this may be a term you're vaguely familiar with from Bazel. And in Bazel, it refers to the kind of arcane system for configuring C++ tool chains. And that used to be a protobuf that you had to write, and now the protobuf has been turned into Starlark. But before it was a custom declarative language for generating compiler flags, CrossTool was a script written in the early aughts by a guy named Dan Cagle. And the script was for building GCC cross compilers and their related runtimes. With a mere few thousand lines of shell, CrossTool automated the previously fragile process of creating GCC tool chains for various architectures. Dan's work has been going strong in this project, which still exists today, called CrossTool NG. And CrossTool NG is kind of a Swiss Army knife custom toolchain builder. You select what versions you want using a very sophisticated configuration system in the target platform, and then hit go, and target CrossTool NG spits out a toolchain after a few hours of compilation churning. Of course, the original CrossTool proved to not be customizable enough for everyone. Google, in particular, developed its own version to build something called Gertie, its internal C++ toolchain and runtime environment. We know about this, funnily enough, due to the Google Search Appliance. What is the Google Search Appliance? Well, if you were a large company before about 2010, you could buy all this yellow box pictured here, and then you could go stick it in a rack in your corporate data center, and it would use Google Search Magic to index all of your company's internal documents without anything ever leaving your network. So very enterprise secure. Apparently by 2016, though, the cloud felt sufficiently safe for enterprises, so Google ended up killing the Google Search Appliance. So it only lives on as an antique now. A delightful consequence of this being a physical device, though, was that the GPL forced the release of much of the open source software in the Google Search Appliance, and in addition, the tools that were used to build that software. And of course, the software is naturally hosted on another discontinued Google service, Google Code. But anyway, if you dig through the archives in Google Code, you can find a script called buildgerty.sh. This appears to be Google's fork of Dan Kegel's cross-tool script to build Gerty. So I've talked about cross-tool ng and Gerty build as forks of this cross-tool script, but turns out this is not the only public one you can find. There may be many more hidden away in proprietary code bases that we don't know about. But at some point, I needed to make a script like this, and neither cross-tool ng or the original were doing it for me, so I had to make my own script. And when I did that, I had to make this awesome ASCII art diagram at the top of my script showing the heritage of it. And I kind of enjoyed that because it felt like I was joining a rich software engineering tradition by writing this kind of shell script. So what are these shell scripts like actually doing, though? Well, it can be summarized as just compiling everything over and over again until we get something that's reproducible enough. And we can think of that in several different stages. So in the first stage, we just have the host bootstrapping compiler, and we have the source for our compilers and tools and runtimes that we're going to build. And we use the host compiler to build all those things. And the goal of that stage one is to get us a roughly working toolchain that we can use to recompile everything in stage two. The output of stage two is assumed to be good because it was compiled with a trusted compiler. In stage three, we do the whole compilation once again to ensure that the toolchain executables are linked against the final runtime libraries and to check the determinism of the build process. We could even make a stage four where we run the stage three process again to make sure we get the same result if we were particularly paranoid. It's not all that complex conceptually, but I have to say when you're writing the script, it sure feels like you're in the weeds because at various points in the script, you have to keep track of which headers from a particular stage and which binaries from a particular stage you are supposed to be using in a particular step to build another stage. And it gets quite convoluted for a human to keep track of, but it's a fun exercise. And that's all I have in this talk, folks. Thank you very much for listening in. I really appreciate your attention, and I sure hope I'm able to see you all in person next year. So Hermeticity is very good for build tools, but it's not so good for humans, and I miss the face-to-face interaction of a conference. So until next year, bye-bye.
Hi, I'm Austin Hsu from Blue River Technology, and I'd like to talk about testing on embedded systems with remote execution. So I like to work on things that move. For fun, I spend time with high school students and we program robots. For my job, I program large agricultural equipment. We've seen in previous Bazel conferences that folks use Bazel for autonomous vehicles. BMW gave a presentation a couple years ago. SpaceX has been using Bazel. I find software a lot more interesting when the thing that I'm programming moves. So at my previous gig, we were working on Class A trucks and doing driver assistance systems. Imagine I came to you with a change I wanted to make on the vehicle and said, hey, can you go take this out on the road and test it? What would constitute enough testing for that? If I told you I ran the unit tests on my laptop, is that good enough? Would you feel comfortable? If I told you I ran all the nightly tests on a big server, ran a bunch of hours of testing, would that make you comfortable? What is enough testing? Running tests on your laptop is not quite the same as running them on a target. For the vehicle I showed you before, that's a 32-bit ARM machine, which is a bit different than your 64-bit laptop. Pointer sizes will change, size of ints, size of longs can change. Those will have different libcs, lib standard C++ with different bugs and different issues, different operating systems, different kernels. For us, a big one we run into is your laptop's going to have a different GPU than the target. These just aren't quite good enough when you're trying to trust that your test results are applicable. so you can roll out your software. So these embedded systems are different than servers. They're going to be part of a mechanical system generally, something that moves. There's a lot of custom hardware. You'll have custom boards, custom peripherals, they'll interact with physical things. This is all quite different than your server. Sometimes you can get off-the-shelf boards that'll do what you want, but that's not always possible, and those are generally pretty bespoke. A lot of times these systems are ARM processors, or we've seen some PowerPC processors, so that's going out of style. Sometimes you get x86 processors in there, but that's reasonably rare. And while they'll run Linux, sometimes you'll get other operating systems like QNX, VxWorks. Sometimes you'll run a much more bare metal RTOS or no operating system at all. It's actually something else that happens. So what does development look like for these machines? Generally, you start by programming something up on your laptop or desktop, trying to make sure that you've got code that'll work and that you're comfortable with. When you're happy enough there, you'll cross-compile on your laptop for the target and produce a binary, and then you can copy it over to your target and run it and see how it performs. So if we look at what Bazel is going to do when we build a target, this target, for example, I'm using the protobuf compiler to make it a little more interesting. So the first thing we have to do is we have to build the protobuf compiler. That'll generate the proto-C binary. From there, we can run that protobuf compiler to generate our .pb, .cc, and .pb.h files that we then want to build with our compiler again and build them for our target, which will be our laptop in this case, and then produce a final binary. If we look at how that changes when we're doing our cross compilation, a lot of it actually stays the same. We still need to build the protobuf compiler and generate our .pb.cc and .pb.h files. And then we'll use, in this case, ARM Linux EABI GCC. This is a cross compiler that'll take our source code and generate ARM binaries. And then we can use that to generate our ARM target. Bazel understands 3 platforms when you're building. There's your host platform. This is the place where the Bazel client is running. There's your execution platform. This is the place where Bazel runs the compilers. And then there's your target platform. And this is what Bazel is trying to produce executables for. If we look at a super simple case here, I'm going to be doing everything on my laptop. So I'm running my Bazel client on my laptop. Bazel's then going to run the compilers on my laptop. And then I'm trying to build binaries for my laptop. So all 3 of those targets are my laptop. If we're going to do a cross compilation on my laptop, it's going to be slightly different. So the host and execution platforms stay the same. We're going to still be running Bazel on my laptop and running the compilers on the laptop, but you're then trying to generate binaries for your embedded platform. If we look at a remote build, so we're going to hook Bazel up to a remote execution cluster. You're going to run your Bazel client on your laptop, but you're going to actually run the compilers on your servers. And then depending on how you set it up, you'll run your targets. You'll be trying to target your server as well. And if we do go full hog here and we try and do a cross compile with our remote execution system, we'll be running Bazel on our laptop, but the compilers run in the cluster and we're targeting our embedded system. So there's generally 3 ways that I've found so far through my exploration through the last 4 years for how to try and test with embedded systems. So 1, we can try and run Bazel on our target, try and run it on our embedded system. Another strategy which we'll explore is we can build cross binaries with Bazel on a server, and then we can copy the binaries over to a platform and try and run them. Or we can figure out how to use remote execution. So Bazel running on the target is not always super straightforward. Bazel distributes a large number of binaries for a large number of targets, but they don't necessarily have to include your target. And this has gotten better over the years. If you get past that and you find a version of Bazel or you build your own, you're going to start to run into certain rules have checked-in binaries. So we quickly learned that rules node.js has an x86 node checked in there down on the bottom. Rules goes a little better. It has a bunch of different Go compilers checked in that you can use for different architectures. You may or may not have the one you need. Rules Docker has similar challenges. There's some executables it needs. If you go look at Rules Docker and dig deep down in the guts, you're going to find it's going to download a Go puller, which is for downloading Docker containers. And you can see here, this is a pre-built Go puller for Darwin. So this is the type of stuff you'll find where it was just too hard for somebody to build all this from source as part of the build. If you get through all that and you have a build, you're going to start to learn that your embedded system is not all that fast. Some of the ones that I've worked on have 128 mega RAM or even less. And if they have 1 or 2 cores and some pretty slow disk, that gets to be a pretty sluggish build, which makes you question if that's really the right answer. And then it's a little tricky then to start to get developers access to platforms so they can test. When I've done this, it's taken a couple hours generally to get everything reset up every time you have to go debug a embedded system problem. And just pretty quickly, you start to ask yourself, am I doing the right thing? And it feels like I'm fighting the flow. Is there a better way? So our second strategy we were talking about is there's a flag called run under, where you can tell Bazel, run your executables under this script, use the script to run them. And we could go code up a script that goes and copies the executables to our target and then runs them and copies the results back. And pretty quickly, you start to want to scale it up. So how do I have multiple of these targets I can run work on? Networks aren't perfect, so how can I start to deal with retries? And I want to cache the results. And this is starting to sound awfully like remote execution. And you'd really like Bazel to manage more of this because it already knows how to do a lot of this for remote execution. So this one just doesn't scale super well. So we get down to trying to hook up a remote execution cluster. So really what we want is we want to take our laptop, have it connect to the cluster, and have x86 servers for doing our big builds, and then embedded platforms in there where we can actually run the tests as the final step. And then we can distribute this all. And this does work. So a simplified view of how remote execution works. So the Bazel client first starts by uploading the inputs to your build. So here we're going to upload foo-test.c. Make sure that's in the cache. It doesn't upload if it's already there. And then from there, the client says, okay, I have this action for you to run to do a compilation step. So take that foo-test.c that you know about, run this compiler. Here's some output I want you to put back in the cache and potentially give me back later, and then run it on this platform. So the cluster then goes and runs that action, generates foo-test, the binary, puts it back in the cache, tells the client that it succeeded. And then the Bazel client says, okay, next, let's go and run that test. So it goes and sends out an action for foo-test to run it. And then the worker goes and grabs that from the cache again, runs it, pushes the results. So if we add embedded workers, this gets slightly different. A lot of the first steps all stay the same. We do the same build. We upload the artifact. We go trigger the build of that artifact on the worker. That gets put in the cache. And then for our running of the test, we actually just specify that we want it to run on a different platform. So we say, hey, we want that one on ARM, not x86. And so then it will schedule it on the embedded worker, run it, and push the results in the cache, and then tell the client that it's succeeded. There's another cool thing we can do with this if we want. We can actually go and hook up little microcontrollers to some of these workers. I've done this before to pretty good success. So you build your test into a little piece of embedded firmware that's going to go run your test and prints the results out. So your worker then knows to take that, uses a little script, flashes that firmware onto the microcontroller with your test, and then runs it, and then takes the result back over a serial port, for example, and then report success or failure back up into your cluster, and you're off. So this is how you can kind of get around the limitation of needing to run the entire worker stack on your worker. So how do we configure this? So we're running an EngFlow cluster. So for us, the documentation said add a second pool of workers. So we have our main pool of x86 workers, and then we added an ARM pool. And then in our platform configuration here, we added pool ARM into the exec properties. So now any actions that get annotated with this platform will get scheduled on our workers, our embedded system workers, and we're off. So benefits on this? Well, all this parallelism and caching, that all happens for free. Bazel and the remote execution system already know how to deal with this, so we're just along for the ride. It's super scalable too. You can just keep adding embedded systems, adding servers. You can add more types of systems if you want. All of that happens transparently on the back end and easy to scale up. The part that I really like is you're actually doing your compilations on fast x86 machines that can be in the cloud or wherever. and those can be cheaper and faster. And then the actual execution of the tests runs on the embedded platform that you care about. And a lot of your rules and stuff get a lot simpler. We don't need to modify as many things. And it's actually easy for developers to run tests too. They can just hook up to the cluster and go. So here's an example where I ran a test on my laptop against the cluster for our target system. So we did a Bazel test. We specified the target platform to tell us to do the cross builds, specify our test. And then because we're work from home and not everyone has good internet, we don't turn remote execution on by default. But here we want to say, hey, turn on all the remote execution flags to connect to the cluster. And it just magically works. Here you can see we ran this on the cluster and things were cached and things were actually successfully run. Downsides, you're now bit off the maintenance of a remote execution cluster. That's not always free. You get other wins from doing that. You're also going to find a fair amount of sandbox leaks. We found all sorts of things that were installed on our laptops, but not necessarily sandboxed into the servers. I actually view this as a positive thing because it catches all the unknown dependencies and makes sure your build's more hermetic and reproducible. And because now that you're a little bit more removed from running the test, it can be a little harder to get it under a debugger if something goes seriously wrong. There's a small asterisk to all this. Bazel test foo by default runs foo on the execution platform, not the target platform. This is a decision made from Bazel in the past. That's not necessarily what we want in this case. So what we did is we grabbed a patch from Ulf that goes and changes that, adds a flag to Bazel that makes it so that the platform that you're running the test on is the target platform, not the execution platform. And that's how we were able to steer those actions correctly. There's been some discussion in the Bazel community about what's the actual proper way to do this, and test execution groups appear to be the way forwards. So there will be some activity in this space, and hopefully we can get something figured out. So here's one of our builds from before. So it was a 45-minute build. This was reasonably average. There's 4 main builds here. We're building on x86 for x86 as a faster build. Then we're doing our cross build, but ignoring the results just to make sure there's no compiler errors. And then we run a subset of tests directly on our embedded system, which here you can see is the long poll. That was 44 minutes, whereas our other builds were about 21 minutes. And then we have a separate UI build because we couldn't figure out how to get that to work with all of this. When we switched over to running tests against our embedded system in our remote cluster, we were able to drop 2 of those builds. The UI build got consumed into the rest of the Bazel build, and we dropped running on our embedded system, and we're able to run the tests directly. And we got significantly faster. So our embedded system tests are now much more parallel and cached and all those great things, which is a huge win. So we saw our worst case builds before where you hit that core.h header file that rebuilds the worlds. We're hitting us at about 2 hours. Those worst case builds now come in at about 25 minutes, which is not significantly more than the average build, which is pretty awesome. We've been able to move all of our builds over to Bazel and dropped everything else. So there's just a lot less interactions to work with. And everything's gotten a lot easier to maintain. We have fewer patches to third-party rules. We're just much happier. And what more can you ask for? So thank you for coming. Hopefully you learned something about how to think about embedded systems testing with Bazel and got to see part of the journey I've been on in this space for the last 4 years.
Welcome to Bazelcon. I prepared this presentation to share with you what are our current plans for the Wrangler rule sets in Bazel, and I will also give some advice how to make the Starlark rule set better. And by better, I mean more performant. I will split this presentation in 2 halves. First half to tell you on what our plans are, and the second part to actually go through an example of a Starlark rule set. So let's first go into what the problems are. Bazel code base is extremely large, It contains around 500,000 lines of code. And a part of this code base are also language-specific rules for bigger languages. Those are Java, C++, Android, Python, Shell, and they occupy around 150,000 lines of code. The problem with that is that this makes changes to such rules difficult because they are complex, and the author of the rules also needs to know the Bazel code base well. Another problem is that sometimes those rules are intertwined with Bazel core, and this makes also maintenance on the other side hard because whenever we maintain Bazel core, we might find some special casing for those rules. Third problem that happens for open source developers is that there are no unit tests published for the language rules that are part of Bazel. And this makes contributions hard because after you make the contribution, if we review your PR and accept it, we still run the tests, and those tests might be failing. Our solution to this is Starlarkification. Starlark is a subset of Python, and you can write new rules using it. Comparing to native rules written in Java, the rule creation API is much more narrow. So what we are doing currently, we are rewriting native rules to Starlark. We are going to re-implement all the rules and their tests. And we would like to eventually move those to their own repository separated from Bazel. We are making progress layer by layer, starting with the outer layer, which means rule definition and rule-specific implementation, which is not shared among the other rules. And we are also implementing native aspects that are used to Starlark. At the moment, we are working on Java and C++ rule sets. We are finishing Java library and CC library. And we plan to progress after this to middle layer, where the providers and common modules are. If it's viable, we plan to also rewrite inner layers where there are C++ compile action and Java compile action. Because the interface to the rule creation in Starlark is much narrower, we are also reducing technical debt along the way. We always first try to use the interface that we already have. Sometimes we need to deprecate some of the features in the rule sets. We are doing this carefully, not to affect any of our Bazel users. And we often also need to migrate our internal code. Sometimes we also decide to expose new features to Starlark rules in general, but we are also doing this carefully because we don't want to introduce unnecessary complexity to Bazel's core, and because we also don't want to allow weird use cases which would be hard to remove later. One of our main concerns rewriting the rules to Starlark is performance. Starlark is in interpreted languages, and there's an inherent risk that the execution is going to be slower, at least CPU-wise. We gave ourselves the goal not to regress performance, both in memory and CPU-wise. Current result is that newly written rules in Starlark actually don't cause CPU regressions. They are only smaller ones. Um, what so right now we've written a couple of rules to Starlark, and this gives us a unique opportunity because we have identical implementation of a rule in Starlark and native implementation of it, and we can easily compare those. Doing the comparisons on those, we found initially that we caused quite a large memory regression. So we've worked on removing it. And while we were removing it, we actually improved performance of all the rules that are written in Starlark. We improved it by about 1.5% without the authors of the Starlark rules needing to do anything. But there is still some things that need to be taken care by the Starlark rule sets, and what to do, the advice I will present in the next part of the presentation. So I will start with a simple example, what not to do. And this is mainly concerned about memory consumption. So here is a simple rule that takes input from toolchain, then it creates an output file, it collects argument list, and then it runs a simple action, printing a nice progress message along with it. And then the output of this action is returned in a custom provider. There are some performance problems in this example. They might seem minute, like nitpicking. However, when this rule is used on 100,000 targets, those problems add up and they cause quite a large regression. First thing to notice in this example are the arguments lists, which are being concatenated together. So why should one avoid list concatenation? Starlark does not distinguish between lists and list builders. So whenever you use list concatenation, like in this example, Starlark would create a new singleton list plus a resulting list. You can get to the behavior that is closer to a list builder if you first create the list and then call appends and extend calls on it. So this is what we are going to do. Another thing to notice is that now arguments are still passed into an action like a list. Bazel provides an interface for arguments construction that's available under context action arguments. And this interface can be used to further optimize the memory consumption in the rules. So the interface allows you to add arguments, add a list of arguments, or a depth set of files to it. And using it, we can further optimize it by adding arguments. So what is actually the problem with memory regression in Bazel? Bazel, after the analysis phase, where it calls all the rule implementation functions, retains all the actions and all the providers in memory. This then later serves to speed up incremental builds because the implementation functions don't need to be reevaluated except when they change. So in this example now, Bazel will retain all the formatted strings that are added here as an argument. And if this action is called 100,000 times, all those string references are being retained. So another advice is to avoid string manipulation and formatting, because every time you add a formatted argument, this will create a new reference. The add function call and progress message calls actually both accept formatting. A progress message call actually accepts placeholders for the most common use cases. So what you can do in this example is use the formatting argument for the add calls and use placeholders for the progress message. Those were quite recently added. We are not there yet. Another thing that's happening here are calls to shortcut. The add call also accepts the artifacts directly. So it's better to use those. And it also accepts a list of artifacts or depth set of artifacts. So those can be used directly. If you use the short path, the problem that is created is that Bazel in the background will create a new reference to path fragment. This part is not optimized. Whereas if you are using artifacts, you already need to retain them because they are returned in different providers. The last optimization that was quite a surprise for me is happening in the toolchain, where options are passed as list of strings. This is one of the rare use cases where a depth set of strings can be used and is actually beneficial. What's going on in the background is that lists, the underlying array for lists is actually quite hard to keep a single reference to it. But if you use a depth set is constructed in a way that's actually really hard to duplicate a reference to it. So if you replace this with a depth set, you can have actually quite a large savings. So example where we did this was on Java toolchains, where Java options are now passed as a depth set. Because Java, there are quite a lot of Java targets. All those options are retained as a single reference, and this means very much smaller amount of retained heap. So coming to the end, this is now a good example using all the advice I've gave. If we go quickly through the summary of advice, the essence is that you should, during Starlark rule implementation, consider how much objects are created and which of them are retained on heap. So you should avoid manipulating lists or strings. And there are also some hidden traps like calling short paths. And it helps if you always use depth sets in the providers, because this will keep a single reference to them. So in short, our vision for the rule sets in Starlark in Bazel are that rules, we move all those rules to Starlark. We are making progress on it. We expect that the outer layer of biggest rules like Java, C++ is going to be done by end of this year. More visible results should happen mid next year, when we expect to start populating rules repositories with the implementation and corresponding tests. What we would also like to achieve is that Starlark rule sets are on the par with the native ones. This means that we don't want to make any special exceptions for big languages. Last but not least, we would like to make major rule sets easy to contribute. So having the unit test together with the rules, it should be easier for the contributors to understand the rule sets and to modify them. And also you are then able to run the tests yourself. So thank you for your attention, and I hope this makes the lives of Starlark rules owners easier.
Hello, my name is Sarah. I'm a junior studying computer science on the artificial intelligence track at Stanford.
And hey, my name is Umar. I'm a senior at Stanford University studying computer science, also on the artificial intelligence track. And this is our presentation, Predicting Basal Build Times Using Machine Learning.
So let's start by discussing why we chose to do our project on this topic. Well, our first and most direct goal was increasing engineer productivity. So a lot of you guys are engineers, and so you'll understand that when you start building your code, you frequently take a coffee break. Sometimes you even start another coding project. But how do you know which one of those things to do? Well, that's dependent on how long the build will take. So by predicting basal build times, we allow you guys to be better able to allot your time as you see fit. Our long-term goal is to decrease energy consumption. And the way that predicting basal build times relates to this is that by predicting times, we can kind of flag which builds are the most problematic or the longest builds. And then we can focus in on those builds, hypertuning parameters such as the jobs flag, and trying to make sure that we can make those build times specifically more optimal in general, decreasing energy consumption over time. So now we're going to talk a little bit about the data we fed into the algorithm. So our data set came from the Basel project on GitHub. And the reason we chose the Basel project is that each Basel build has a build event protocol, which allows us to be able to get the CPU time it took for the build to happen, which is exactly what our output data is. In general, we took 500 commits from this GitHub repo. The reason we chose 500 is a constraint on our part of time as well as our computers. It took us about a whole day just to pull 500 commits. And then the way we spread out those commits was 300 training commits, 100 validation commits, and 100 testing commits.
So why did we choose commits to Basel as our data set? Well, our goal was to understand where changes in the code base affected build time. And to best understand that, we wanted to see in each commit which changes were made to affect the build time that was found in the build event protocol of each build. And further diving deeper into why we chose certain features within each commit, well, we wanted to understand what changes were made. And that kind of broke down into two different choices. Did we want to look at which files were changed, or do we want to look at what code itself was changed and how much of it was changed? We decided to go with file path with the understanding that 100 lines of code changed in a file like source main is much more impactful based on file dependencies than, say, 100 lines of code changed in third party. And for that reason, our goal was to relook at the file path changed and understand where in the code base those changes were made to affect the build time. And so that leads us into our input data, which was we took each file path within each commit to Basel and we broke it down into pieces. And the pieces that we chose to break it down into were the prefix of the file and the file type at the end. And what we did was that for each file path that was changed within each commit, we took the prefix, for example, source main, examples, scripts, third party. We took the file type, for example, C, C++, HTML, and we aggregated that data to understand which file prefix was the most common prefix changed and which file type was the most common file type changed within that commit. And then our next step to pre-process that data for our linear model, or our machine learning model, I should say, is to put them into TensorFlow categorical columns. Similarly, for our output data, we obtain the build event protocol for each commit. This harks back to why we chose to work with Bazel in the first place, is that it gave us access to this very clear output data of the exact build time that was within the timing metrics of each build event protocol. And based on the CPU time of each build, we were able to understand exactly how long each build took based on the file type and the file prefix that was changed for that commit. And so using this data, we were able to start thinking about our machine learning model and exactly which model we wanted to pick. The first thing that we had to decide was whether we were going to work with a supervised learning model or an unsupervised learning model. What we understood about the supervised learning models was that they took in very explicit labeled input and output data. And what that allowed one to do is that you can get very clear accuracy because you understand exactly what you're looking for. There are very explicit results that you can say that if this is the build time, we are exactly 5 seconds with our prediction off of what the exact build time should be. On the other hand, with unsupervised learning, you don't need that labeled input and output data because the goal is to find patterns and clusters of data within that raw data. And for that reason, it was very clear for us, because we had access to very explicit input and output data, to go with a machine learning model, and more specifically, a linear regression model.
So the algorithm we ended up selecting was linear regression, which is a supervised learning algorithm. And these are the main parameters for linear regression. So the two most important parameters on this slide are learning rate and batch size. So too low of a learning rate means that the algorithm's training will progress very slowly, and as a result, you may not be able to account for all of the data, or you'll end up waiting way, way too long for the algorithm to train. Too high of a learning rate means that the model will converge too quickly to a suboptimal solution, and it won't account for all of the nuances in the data. And then batch size relates to learning rate. There are ideal batch sizes for learning rates. So we wanted to make sure that we got the ideal learning rate batch size combination, because having that ideal combination would keep us from having issues such as overfitting. And so there was a lot of guess and check involved in 0.1 and 16. Other than that, you see the optimizer on the slide. So our current optimizer we chose to use was SGD. That's a very commonly used optimizer. Its only real drawback is that if you have a lot of data, it can be pretty slow, but that wasn't a problem we encountered. Our metric for accuracy was root mean squared error. And so we knew that the lower this value, the better we're doing. And finally, an additional kind of layer we added to linear regression was feature crossing. So walking into this project, we had no way of knowing if the relationship between file type / prefix and CPU time is linear, or whether it's exponential or anything else. And so by doing feature crossing, we were able to use a linear regression model to make predictions for a relationship that was potentially not linear. Yeah. So now digging a little bit into what our actual results were. So in terms of accuracy, you guys see two different graphs before you. One is with feature crossing, one is without. And there's a couple things that I really want to highlight here. The first is that you see that the training and validation data lines are about the same, and that is a very good thing. If there was a significant difference between the two, we would know that there is definitely overfitting in this model. The other thing that you see in both of these graphs is that there's no like kind of sharp, super sharp turns. You know, you don't go from like no error to a lot of error all of a sudden. Any super sharp turns like that would also let us know that there's overfitting. On the converse side, you see that our average error was around 5,600 or 5,700 milliseconds. And that's pretty good as well, because our build times were, anywhere from 10,000 to 50,000 to even 100,000 milliseconds. So that value really tells us that for our bigger builds, which are the ones we really care about, our error is relatively negligible. And then finally, you see that the difference between the error with feature crossing and without feature crossing is not that significant. It's really only 100 milliseconds. And that tells us that the relationship between file type / prefix and CPU time likely is linear.
So taking a step back, what this means for our model accuracy is that we can predict Bazel build times with a 6-second margin of error. That is very significant because for builds that take longer than 1 minute, 2 minutes, 5 minutes, 30 minutes, an hour, it is very, very useful for the engineer to understand that when you kick off a build, within 5 to 6 seconds of error, you'll know that this is going to take X amount of time, and you are free to do whatever you'd like as an engineer with that time, and thus increase your productivity. And this leads us into our next steps, which is kind of like a roadmap for where we see this project going forward. There are two things that we can do to increase the accuracy of our model. The first thing is collecting more data. Due to time and resource constraints, because we had to let every single build run on our local machine and to be able to collect the output data of the build times, we had to let each build run in its entirety, one after the other. We could only collect 500 pieces of data out of almost 30,000 commits to Bazel. So simply taking more time and more resources to collect more data, we will be able to better understand the changes in the code base to Bazel and how that affects the build time. Another thing is increasing the granularity of our data. As I mentioned earlier, we took the file paths that were changed and we broke them down into the prefixes and the file types and further aggregated that into the most common prefix and the most common file type. Rather, what we could do to increase the granularity of our model and better predict build times is we could take in that entire file string with the prefix, the pieces in the middle, and the file type, and also take in every single file path change for every commit to better understand the data. And with those in mind, we can start building towards a more accurate machine learning model to predict Bazel build times, and then further use that model to understand which builds take how long and how we can use that data to further optimize build times and thus work towards our largest goal of decreasing energy consumption. Thank you so much.
So thank you so much for listening to our presentation, and let us know if you have any questions.
Hi, my name is Eugene Yokota. I'm a software engineer from Twitter. My pronouns are he, him. My visual description is an Asian person wearing a dark t-shirt with a bookshelf in the background. Today, I like to talk about third-party dependency resolution in JVM and the solution that we're developing in Twitter called Bazel Multiversion. So a little bit about the context. I joined Build Team at Twitter last year. So I'm relatively a newbie in Bazel. However, I've been maintaining this build tool called SBT that's popular in Scala ecosystem. So in a way, I can say that I'm more like familiar with messing with the jar files from the Maven Central in the binary ecosystem, especially in the Scala. So I like to start with this one question. Is monorepo a monoversion? And if so, are we all connected? Well, it's certainly not the case with Twitter. So we have around like 1,000 plus incidental multiverses. And here we define multiverse to be a unique combination of external dependency versions. And similar to traditional build tools like Maven or SBT, Pants resolves these external dependencies at the top level targets, like test and Scala binary targets. So essentially, individual targets could form its multiversion. So stepping back a little bit, let's look at what monoversioning and multiversioning are. Monoversioning is basically you have one version of Kafka or Mockito or Guava in the monorepo, whereas multi-versioning, you have multiple versions of Kafka, Mockito, or Guava. And I think many people associate monoversioning as almost like a characteristic of the monorepo, but we actually think it's more of a two-dimensional design space. On one axis, we have monoversioning versus multiversioning, and on the other hand, there's a unified versus the ad hoc dependency resolution. So conventional rules such as rules JVM external and Bazel depths are on the top left quadrant. These are fast, correct, but in a way inflexible because of the monoversioning. So whenever you adopt one library, everyone basically needs to be compatible with that particular adoption. Pants as a build tool that we have been using at Twitter for the monorepo build is sort of on the bottom right quadrant, where it is ad hoc resolution but supports multi-versioning. So in a way, it's a little slower and it could be inconsistent within the monorepo, but it gives us the flexibility to do incremental adoption of some specific dependency. So in a way, we can think of it as these are the two competing sort of like a way of thinking. But we can't really do ad hoc resolution like just by the design of Bazel, right? It's because that will be incorrect, meaning that the result would end up picking up things that is not part of the input. So another thing is that even if we somehow could force it, that would end up squandering the benefits of adopting Bazel, which is its ability to catch things more correctly. So as a combination, we're working on Bazel multiversion, which basically takes the unified resolution of Bazel, but implements the flexible incremental adoption of the multiversioning. So this is more sort of like looking at it as like why are the benefits or the, I don't even want to say benefits because it's not one is clearly superior, but why, companies like Twitter may use multi-versioning. So from the more like a business use case. And this is like a curve, sometimes called a crossing the chasm curve or the innovation dissemination curve. So one side left is the early adopters. So there could be cloud service SDKs what wants to use, let's say, like a Google Cloud, and these could be moving much faster. And then there could be newer versions of databases like Kafka. They may be moving faster, but the huge chunk will be the paved path, and that will be where the majority of the monorepo users would use. And on more stable side, there could be batch jobs, like map reduce jobs that needs to be stable because it's running inside of our data infrastructure. And on more of the legacy side, there could be persistent data structure that needs to be retrieved back in the exact form. And that could be persisted into database or some sort of like a protocol. So these are some of the phases that innovation adoption may go through. And by using multi-version, the teams that are innovating faster can basically go ahead of the pack and adopt. And on the other hand, the team that needs to be super stable can keep sort of like behind the pack when even though majority of the companies have moved on. So Bazel multiversion is available on GitHub under Apache v2 license. This is the open source program that we created. To sort of like give credit, the original author is Olaf, and he came up with a lot of the concepts behind this stuff. And we work on with a team. So it's not just like me presenting, but a bunch of people have worked on this. The input we use build file, but sort of like a build-ish file, because this is not an actual Bazel file, is the same sort of like a formatting that's used in PATS. And here, like, there could be multiple inputs. And this is an example of the Starlark binding that I created that looks exactly like the PATS file. So we define a build that says jar library, and in there we can define the version of the guava we want. And so we could have guava 29 and guava 24 and different versions of the guava in here. And when you run multi-version, this basically, so it says multi-version import build, and that will import these build files. It will generate like traditional, so like a ruled Scala rules. So first it will create the HTTP file, and that includes the URL and the SHA-256 of these jar files. And then it will create the Scala import, like representing the dependency graph of these external dependencies. To use these third-party dependencies, you basically refer to it as like @maven // colon third-party, and then say guava guava, and that will pick up all of the guava and its transitive dependencies of this target. And so here's how sort of like the rough draft of how the resolution works. So there are two kinds of dependencies. The one in the solid lines are the direct dependencies, whereas the ones in the dotted lines are the transitive dependencies that we pick up as a dependency of the dependency. So the initial resolution is done using Corsia, and that essentially forms a mini graph of all of the direct dependencies that's in the buildish file. And here we see an example where Kafka 2.6 and Kafka 2.5 are picked up. And that is actually an example of dependency conflict where you have the same module, but two different versions. So to resolve these conflict, we perform a secondary resolution where we bucket all the transitive dependencies into basically buckets per module. And by default, we assume the early semvar, which is a variant of the semantic versioning. So all of the 2x goes into a single bucket. So 251 gets evicted in favor of 260. But because we're assuming the semantic versioning, if it's 2.6 and then let's say it's Kafka 3.0.0, these will be bucketed differently, and we'll basically now have a multi-version situation. So to tweak the resolution, we have a whole bunch of different knobs. So we'll look at like some of the main techniques we use to tweak the resolution. The first is sort of like a pinning minor version. And you can think of it more like a closer to the techniques probably used in the mono versioning world, where we want to tightly control the particular version. And let's say we don't want the eviction to be happening, and we do want to use Kafka 2.5. And you basically promote the transitive dependency of Kafka 2.5, 2.6 into 2.5 in this case. So the direct dependency is by default given force equals true. So that will be pinned to that. So in this case, the pub sub light Kafka would pick up Kafka 2.5 as its transitive dependency. So if you've used Kafka before, especially Kafka streams, you might be thinking, oh, I don't really want these evictions to happen. And we consider Kafka 2.4, 2.5, 2.6 to be different libraries that we want to track. In this case, we could increase the granularity of bucket by setting it to PVP. So PVP is a term used by Corsia as well as SPT to mean that the first two segments of the version, like 2.1, is a major version. And this comes from Haskell's package versioning policy. So by calling it PVP, we can increase the granularity. Yeah, so in this case, back to Kafka 2.6 and 2.5, these will be tracked separately. The other way is to sort of like decrease that granularity, and you can say always. In this case, everything gets bucketed into the same single bucket, so we can treat them in the same way. But actually, we don't really want to use that because that's sort of like more of a big claim that any of the versions are sort of like interchangeable. So to take a little more conservative approach, we could do this thing called unification. And that's basically we would exclude a specific one from a particular target. In this case, like the pub/sub light, we can exclude 2.6 and then manually point to Kafka 3.0. So in this only particular case, we will perform this like a unification process. And I sometimes call this graph stretching because we're stretching the graph sideways. And in the build file, it looks like this. So we add the excludes for the Kafka clients, and then we add a dependency pointing to the one that we track. So here are the summary of the tweaks. We can pin things, we can increase or decrease the granularity, and a lot of times we do unification to resolve the major version conflicts. So next, we want to look into resolving the diamond problem. So what is a diamond problem? So in the earlier example, we said there could be Kafka 2.6 and Kafka 3.0, right? So what if you have a target that consumes both of these two things? So by default, Bazel doesn't know the context of these jar files because in Bazel, the dependency graph is unified with the task graph. So what ends up happening is on the class path, you will end up with both Kafka 2 and Kafka 3, which is not great. So one of the ways we tackle this problem is that multi-version provides a linter. And you can say multi-version lint, your target name, and this will point out saying, hey, your target contains like multiple versions of GAX and multiple versions of Guava. And here we have like a Guava 2.5, 2.6, and 30 on the class path. So we run this nightly job for all of the targets, top level targets, to detect if there are any of these conflict that's happening in our monorepo. And then to fix it, we can use this like a unification process again to basically stretch saying, oh, instead of having like Guava 2.6 and 2.7, we'll just unify it towards Guava 2.7. The other more sort of like an interesting technique we provide here is the library cross-building. So let's say we want to wrap Kafka using Kafka utility or Kafka util, and given the same source code, we can provide a cross-building facility so that the Kafka util can be Kafka util for 2.6 as well as 3.0. And we can do that by writing this thing called cross Scala library in the buildish file. And it will be looking at the same set of the source code, but we can pass this like a Kafka cross, which is a list of two dictionaries, in this case, like Kafka with the blank and Kafka with 2.6. And these will essentially get substituted under -Kafka as either blank or -2.6 and expand into two targets, just like this. So one will be Kafka util with nothing, and the other will be Kafka util underscore Kafka underscore 2.6. And they will be looking at two different dependencies. So this is one way we can provide like a cross-building support to basically support both Kafka, different versions of Kafkas inside of the monorepo. In case that that is not enough, there is sort of like a last-ditch hack that we also implement. So we really don't want to have a situation where there are multiple Kafkas showing up inside of the class path. So in case that there are multiple conflicts, there is a tertiary resolution that we implemented inside of the ruled Scala. So this is a custom phase that we injected into ruled Scala. So whenever you do compilation or testing, we will deduplicate any conflicts. So the compiler would only see one of them. Typically, we don't really want to resort into this because there could be essentially inconsistencies between what the compiler would see and what the Bazel query is going to return. So to wrap it up, Twitter Bazel multiversion is the open source solution that we're exploring to provide multiversioning support on top of Bazel. And it's a unified multiversioning to get both the speed as well as the flexibility. The initial resolution happens using Corsair, the secondary does the bucketing, and tertiary is a resolution that happens at the target level. And to resolve the diamond problem, there are multiple tools that we offer, including linting as well as cross-building, and like I said, the tertiary resolution. Lastly, I'd like to give shout outs to the several people who worked on this project. Olaf, like I said, he came up with the initial design as well as the implementation. Matan, I work with together closely. He implemented all the complicated exclusion rules as well as the rules around inter-third party dependencies. And Angela implemented machine readable logging as well as a nightly linting process. Thank you.
Hello everyone, my name is Xiaoyi Shi. I'm a software engineer from Tencent. Today I'm going to share our journey of migrating a gigantic iOS app to Bazel. The app we migrated is QQ, which is a beloved instant messaging app in China. Compared to other instant message apps, it comes with a full pack of entertainment features, like games, short videos, and etc. The earlier stats show that QQ has over 700 million active users per month. So why do we need this migration? First, because of size. The first version of QQ for iOS was released in 2008. Over the last decade, it has over 8 million lines of first-party code. To make all cool features possible, QQ uses over 300 second and third-party dependencies. Right now, over 200 engineers are working on the project. To make cooperation possible, we have put lots of effort in writing docs and improving workflows. However, navigating through a large code base like this is still challenging, not to mention building and testing. Second, because of speed. As the complexity grows, the app becomes slower and slower to build and test. Even with a lot of optimizations, a clean build on CI will take more than an hour, and an incremental build will take more than 20 minutes. Because of this, engineers prefer submitting large chunks of code to minimize the overhead, which in turn makes quality assurance another challenge. Therefore, we set an ambitious goal for this migration, which is to make the builds 30% faster on CI. And if things worked out smoothly, we want to improve the build and test experience on workstations as well, and eventually improve the performance of the team. Before we start, I'd love to go through some of the attempts we tried earlier. This should help you decide which is the best path forward. The first one is a hack over the existing Xcode build system. It is the most transparent to engineers. The fundamental idea is to override the default CC and LD tools with a wrapper and provide centralized caching ability in that. So when the tools are invoked with the same arguments, we can return the cached artifacts instead. However, as there's no way to guarantee that everyone uses the same version of the tool, and some transitive dependencies may escape from the dependency analysis. As a result, the cache can be easily polluted and cause incorrect builds. The second one is through pre-built modules. We ask the feature teams to break the product into smaller chunks and release them as frameworks. By doing this, we only need to build once, and other teams can download frameworks without waiting for the build. However, this solution turned out to be problematic as well. With Xcode, there's no way to create a strong module boundary. Even with modular design in mind, people can easily use another module's code by mistake. So modules are still tightly coupled with each other, which makes releasing them a huge problem. Most importantly, debugging pre-built binaries is not fun at all. After seeing previous successful migrations, we decided to give Bazel a try. Bazel is known for being fast and correct through hermetic and reproducible builds, so it's guaranteed that we can get the best part of the previous attempts without those pitfalls. After poking around with some small modules in QQ, we realized that migration won't be easy. There are three major blockers. The first one, Xcode encourages basename-only imports and supports recursive search passes. To avoid having performance issues when having too many search passes, Xcode actually extended CLang to support a header map for lookup. However, as Bazel is not bound to CLang, there's no special optimizations for this, which makes the header lookup extremely slow. Second, as I've mentioned earlier, we have switched to a module design. So each module manages its own set of build settings. As Xcode doesn't support config inheritance across the project, there are a lot of inconsistency in those configs, and makes writing build files a nightmare. Last, because we have hundreds of CocoaPods dependencies, and not all of them behave. To those who are unfamiliar with CocoaPods, it is a dependency management system written in Ruby, and uses Ruby scripts as configs. Because of this, people can do arbitrary things in it, and we have seen cases where people run downloaded scripts while declaring a dependency. So making them work in Bazel is almost impossible. With these challenges in place, asking the feature teams to perform the migration will only scare them away. Instead, we decide to automate the process by generating the build files and run Bazel as a shadow build system, so that we will be able to collect performance data without changing a thing, and let the numbers speak for themselves. In a nutshell, we want our users to forget about the build files and let the tool generate them. How do we generate a build file? Let's take a look at an example library target. The most important part is the source and depth, which defines the library and the relation between them. These configs are considered as the foundation of a target. The other part is the build settings, which controls how the compiler works, like the macros and toggles the certain compiler features. To summarize, as long as we can figure those out, we can generate a build file. QQ is written with Objective-C. Let's take a look how OC is built. Here's a piece of OC code, which implements an example class, which has a sayHello method to log a greeting message. This file has three imports: the foundation framework in the angled brackets for logging, the BZC bundle.h in quotes for getting the year of the Bazelcon, and the last one, the example.h for the class definition. It seems quite straightforward, but can you tell which BZC bundle.h it is importing? To answer this, we need to look at the build script. Like all C family languages, build flags plays a critical role. They determine how the source file is interpreted. The -i flag sets a header search path, which in turn determines the actual dependencies of a source file. Other CLang flags are the build settings. Interestingly enough, we need to check the LD command to figure out what source files are in the library. As you can see, the library has only one object file in it, and the file generating that object file is the source file for the library. To sum up, Objective-C is now designed for automation. It has no convention at all, and the configs are everywhere, which makes us wonder, is automation possible? Of course, it is possible. Let's make it work. The first step is to define the problem, which is resolving ambiguous imports. When the compiler resolves an import, there are three factors in play. First, the import statements, then the content of the codebase, and last, the build settings. As shown on the slide, by changing the order of the header search passes will result in totally different build results. This is because when the imports are ambiguous, the compiler will try each of the header search paths to see if there's a header file exists underneath that, and use the first encounter as the search result. The naive solution is to capture all three and resolve imports accordingly. But this is way too error-prone and slow. The intuition is that when someone writes the code, they have a clear idea of what file is needed. But as only partial information is kept in the source file, it has a tendency to deteriorate. So as long as we can preserve this information, we will be able to tell exact file it is importing. To recover this information, our approach is to use step files generated during the Xcode build, which includes all the transitive dependencies of a target. This works because if our users are happy about the build result, the header resolution must be correct. We create a tool to expand imports to the full path relative to the workspace root, so that we can tell the dependencies from the source files alone. The second problem is to figure out the source and build settings. As I've mentioned earlier, this information is hidden in the final build command, and those commands are generated with Xcode magic. After realizing we can't counter the Xcode spell, we settled with the approach of finding the source files for a target from the Xcode project files, and using Xcode build, which is part of the Xcode toolchain, to figure out the build settings inheritance, and eventually use Xcode buildsettings.com to translate those build settings to CLang and LD flags. Now we have all the necessary bits to generating a build file. We decide to extend Gazelle for Objective-C. Gazelle is a build file generator originally designed for Golang, but can be extended to support arbitrary languages. As you can see, it's a simplified root build file. It has a Gazelle target, and one can use Bazel run Gazelle to generate build files for the entire workspace. As we have extended Gazelle to take Objective-C related directives, so when running it, it will know which Xcode config file to use. Now all we need is to make sure that people run Gazelle after writing the code. Instead of changing the workflow, we create a small script to run Gazelle from git commit hook. Also, to make it run fast enough, we should pre-build Gazelle in the repository and tune it to perform incremental updates based on the change. With those efforts, no one will ever need to create or update a build file manually. So far, we have managed to introduce Bazel without changing the workflow. However, to finish the migration, we need to use it. Given the size of our app, we need to do this gradually, so that all the changes are well tested before hitting the market. The strategy is to leave Xcode alone, then run Bazel as a shadow, and finally take over. This rules out tools like 12c, as it will jump to the final step and forces everyone to accept Bazel as the source of the truth. The idea is simple. Don't touch the existing Xcode targets, and create a shadow one to build the same source file with the same config in Bazel, then combining the two. We call this hybrid build. The workflow for the engineers stays the same, and because the build files are automatically generated, so shadow targets will pick up changes in the original targets without human intervention. After creating those shadow targets, we can gradually change the dependencies of a shadow target to use other shadow targets. This gives us an independent shadow build graph to work with. Moreover, we can run benchmarks against both build graphs in parallel. The last piece of the puzzle is Cocoa pods dependencies. We have way too many pods in our app. We'd love to use some automation tool to visualizing them. Unfortunately, as I've said before, not all our pods behave, so none of the existing tools works out of the box. As Bazel is already capable of managing external dependencies, so instead of improving tools to support our weird cases, we want to replace Cocoa pods with Bazel someday. We end up with a semi-automation solution. Let our tool generate a basic skeleton for each pod and manually tweak the build files to work. The initial performance was not impressive, so we took the path for optimization. After analyzing all the profiling results, the problem boils down to one thing: dependencies. The short answer is that the fewer dependencies, the better build performance. In practice, you can use tools like include what you use to reduce the number of imports in the source file, which will then reduce the number of dependencies. Also, eliminating precompiled headers will help a lot, as they will become dependency hotspots and slow everything down. And finally, use fine-grained libraries. The glob on Lift is easy to maintain, but it's bad for build performance. First, it will put too many files in the Darwin sandbox and makes it even slower to start. Second, it reduces the cache hit rate, as unnecessary files are considered as action input. Therefore, it's more preferable to create libraries with fewer source files. To illustrate this, here are two identical build graphs. The left-hand one uses coarse-grained libraries, and the right-hand one breaks those libraries to fine-grained ones. The first one will introduce many unnecessary files to the action sandbox, say A123, B123, and C123, while the latter only includes exact files needed for the action in that sandbox. For instance, when compiling A1, only A1, B1, and B2 are in that sandbox. This may sound trivial, but when you put transitivity into consideration, the size of an action input may differ in orders of magnitudes. And we did it. We gradually migrated all first-party code to Bazel in 6 months. The stats from the shadow build on CI over July showed over 50% time reduction compared to Xcode, and over 70% of the builds will finish within 10 minutes, which is way better than the original goal. You may also notice the intersection around the 25 percentile on the chart, which is because the Xcode builds are running on high-performance machines, while the hybrid one uses standard VMs. It's also worth to pointing out, as we are using the hybrid build, Cocoa pods are still built by Xcode. The build time analysis shows that it now the most time-consuming part of the whole process, and Bazel only needs a fraction of the time to build way more code. We have started to ship Bazel build QQ in August, and this migration is a huge win. In the future, we want to switch to a Bazel-first workflow so that we can gain better control over the build settings and enforce module boundaries through visibility control. Make build even faster through remote execution and smarter remote caching strategy. In long term, we want to standardize Cocoa pods as native Bazel dependencies. Thank you very much.